channel. In previous video, we studied important introduction part of matrices and the definition of rank of a matrix. In this video, we study some of the important question paper problems on rank of a matrix. Here is the first problem. Find the rank of a matrix A is equal to square bracket of 1, 2, 3, 4, 5, 6, 7, 8, 8, 7, 0, 5. Here this is a matrix containing 3 rows and 4 columns. That is, this is a 3 cross 4 matrix. Here we have to find the rank for this matrix A means the definition of rank of a matrix says the number of non-zero rows present in a matrix. Here we have to reduce this to a row reduced echelon form matrix. Once we reduce this to a row reduced echelon form matrix, the number of non-zero rows in this matrix is nothing but a rank of that matrix. So let's see how to find the rank for a matrix. First take the given data. Here given A is equal to 3 cross 4 matrix. Here we have to find the rank of a matrix means we have to find the echelon form for this matrix. Precisely we have to find the row reduced echelon form for this matrix. Here in previous video we also studied about row reduced echelon form of a matrix. That means here for this matrix first you have to verify the leading entry of each row is unity or not. That is the first step. Once we obtain the unity element in each row, next we have to find all the entries below the leading entry must be 0. That's the second step. Let's see how to find the rank for this matrix with the help of row reduced echelon form of a matrix. Here first step we have to see first row, first element is unity. Obviously this is the first value is 1, so first condition satisfies. Second, we have to find all the entries below this leading entry must be 0. Here we have to obtain this value is 0, this value is also 0. For that, next step, we have to consider here this is a R1, that is row 1, this is R2 and this is R3. So we have to apply some of the operation, this is nothing but a elementary operations such that the values, that is all the entries below the leading entry is 0. We must obtain all the entries below the leading entry is 0. For that we have to apply elementary operation as here we have to change this R2 as R2 minus 5R1. Here this is R2, that is row 2. We have to subtract this value with some value so that that value becomes 0. So we get here we have 1. So R2 is 5 here. 5 minus simply R1 is nothing but 5 minus 1 is 4. So this value becomes 4, not satisfied. So we have to take this R2 in such a case. This value becomes 0. For that we have to take R2 as R2 minus 5 into R1. Here if we substitute R2 is 5 here. 5 minus 5 into R1 is 1 here. 5 minus 5 is 0. This value becomes 0. In the similar way we have to take this R3 as here this is 8. So R3 is R3 minus 8 R1. Here 8 minus 8 into 1 is 8. 8 minus 8 is 0. Therefore R3 is 0 here. Similarly we have to find this value, this value, this value. Let's see what's the value we get here. A is approximately equal to here first row is same, that is 1, 2, 3, 4, that first row is same. In second row, here we apply elementary row operation as R2 minus 5 R1, this value becomes 0. Here R2 is 6 here, 6 minus 5 into R1 is 2 here, 5 into 2 is 10. It is 6 minus 10 is minus 4. In the similar way, R2 is 7 here, 7 minus 5 into 3 is 15. 7 minus 15 is minus 8. In the similar way, 8 minus 4 into 5. Here 5 into 4 is 20. 8 minus 20 is minus 12. This is our R2 obtained when we apply the elementary row operation as R2 implies R2 minus 5 R1. Similarly, R3 becomes R3 minus 8 R1. Here 8 minus 8 into 1 is 8. 8 minus 8 is 0. Similarly, we have to find this R3. Here R3 is 7. 7 minus 8 into 2 is 16. 7 minus 16 is 9. Similarly, here we have 0. 0 minus 8 into 3 is 24. Therefore, we get 0 minus 24 is minus 24 here. In the similar way, here we have 5. 5 minus 8 into 4 is, similarly 5 minus 8 into 4 is 32. Here 5 minus 32 we get a value as minus 27. So this is our R3. So with the help of some elementary operations, we have obtained here all the entries below the leading entry is 0. Here this value becomes 0. Here the leading entry is 1. First condition satisfies, that is the leading entry of each row is 1. Here we satisfied the leading entry of first row is 1. Next step we have to verify all the entries below this leading entry must be 0. This also satisfies. Next, the first condition is the leading entry of each row is unity. Here we have, here in the first row we have the leading entry as 1. In a similar way, we have to find the leading entry for the second row is 1. Similarly, we have to leading entry for the third row is also 1. For that, the next step is here R2 is 0, minus 4, minus 8, minus 12. Here we have to obtain this value as 1. For that, we have to apply the elementary operation as here we have to change this row 2 as minus 1 by 4 into R2. Here R2 is this value is minus 4. If we divide this by minus 4 means minus minus gets cancelled, 4 gets cancelled, the remaining is 1. So we get a leading entry for this second row as 1. Similar way, third row is here we have minus 9. For that R3 we have to consider as minus 1 by 3 into R3. Here we can take this value as, we can take this as minus 1 by 9. This value becomes 1. But for this we have to take this as minus 1 by 9 means minus R3 is minus 24 here, minus into minus plus, that is 24 divided by 9 we get a fraction value. So to avoid that value we have to take R3 as minus 1 by 3 into R3. Because these are all the divisors of 3. So we can take R3 as minus 1 by 3 into R3. So substituting R2 value, R3 value over here and here, we get a new matrix as here first row is same 1, 2, 3, 4. Second row changes to here this is 0 as it is. Here this is minus 4. This here R2 is minus 4. That is minus 1 by 4 into 4 is 4 gets cancelled, minus minus gets cancelled, remaining is 1. Here minus 1 by 4 into R2 is minus 8, minus 2 minus plus 4 ones are 4 twos are, this is 2. Similarly here R2 is 12 here. It is minus 12. Here minus 2 minus becomes plus 4 ones are 4 threes are. So we get a value as 3 here. The similar way R3 is here this is 0. Here minus 1 by 3 into minus 9 is minus minus gets cancelled. Here 3 ones are 3 threes are. So this value becomes 3. In the similar way minus 1 by 3 into R3 is minus 24. Minus minus gets cancelled. 3 ones are 3 eights are. Therefore this value becomes 8. Similar way minus 1 by 3 into minus 27. Minus minus gets cancelled. That is minus 2 minus becomes plus. 3 ones are 3 nines are. Therefore R3 becomes 0, 3, 8 and 9. So this is our new matrix obtained using the elementary operation as R2 is minus 1 by 4 into R2. R3 is minus 1 by 3 into R3. Next, here we have to observe here the leading entry in first row is 1. In the second row, the leading entry is also 1. For the first row, below the leading entry, all the values are 0. In the second row, this is leading entry is 1. So next we have to achieve below this leading entry, this value must be equal to 0. Next we have to apply elementary operation as R3 gives R3 minus 3 R2. Because here A value is this, that is 1, 2, 3, 4, 0, 1, 2, 3, 0, 3, 8 and 9. So we have to obtain this value as 0. For that here R3 must be equal to 0 means we have to take a elementary operation as R3 minus 3 into R2. In the second step we have to take this value, that is we have to subtract the row 3 by row 2, not by row 1. We have to observe this carefully. In the first step we have to subtract row 2 and row 3 by the row 1. In the second place, that is in the next case you have to apply elementary operation, we have to subtract row 3 by row 2, not by row 1. That is a wrong step. We have to subtract row 3, that is to obtain this value as 0, we have to subtract this value by row 2, not by row 1. So we have to take R3 as R3 minus 3 R2 because here R3 is 3 here. 3 minus 3 into R2 is 1 here. So to achieve this as 0, 3 minus 3 into 1 is 3 minus 3 is 0. So we will get 0 here. For that we have to take an elementary operation as R3 implies R3 minus 3 R2. So applying this elementary operation we obtain a new matrix as here first row is same, that is 1, 2, 3, 4. Second row is also same, that is 0, 1, 2, 3. Here R3 minus 3 R2 is here this value is 0. This value also 0 minus 0 is 0. Here 3 minus 1 into 3 is 3. 3 minus 3 is 0 here. Similarly here 8 minus 3 into 2 is 6. 8 minus 6 is 2 here. Similarly, here we have 9. 9 minus 3 into 3 is 9. 9 minus 9 is 0 here. Therefore, this is our new matrix. Here in the first row, the leading entry is 1. All the values below this leading entry is 0. Here also second row, the leading entry is 1. Below this, we have obtained a value as 0. But in the third row, we have to take the leading entry must be unity. For that, next step, we have to take R3 as 1 by 2 into R3. This is our elementary operation because 1 by 2 into here R3 is 2 here. So 2 gets cancelled, remaining we get a value as 1. For that, we have to take elementary operation as R3 implies 1 by 2 into R3. Therefore, we obtain a new matrix as here first row is 1, 2, 3, 4, second row is 0, 1, 2, 3, third row is here also 0, this also 0, 1 by 2 into here R3 value is 2, therefore 2 gets cancelled, remaining is 1, therefore this value becomes 1, here this value is 0, substituting R3 value is 0. So we obtain a new matrix as this. Therefore, we can conclude that this is an echelon form of a matrix because here in the first row the leading entry is 1, below this leading entry all the values are 0. Here also in the second row the leading entry is 1, below this leading entry this value is 0. In the third row we have to take that is leading entry is 1. So we can conclude that this is an echelon form of a matrix for this given matrix. Therefore, we can conclude that here in the obtained echelon form of a matrix, we have 3 non-zero rows. Therefore, we can conclude that the rank of a matrix which is given by row of A is equal to 3. Because definition of rank of a matrix says the number of non-zero rows in an echelon form of a matrix is nothing but a rank of a matrix. Here this is an echelon form of a matrix which contains 3 non-zero rows. Therefore, row of A is equal to 3. This is about solving the problems of rank of a matrix. We shall move on to another problem. Find the rank of a matrix A is equal to, here this is a 4 cross 4 matrix. Here first row is 0, 1, minus 3, minus 1. Second row is 1, 0, 1, 1. Third row is 3, 1, 0, 2. Fourth row is 1, 1, minus 2, 0. So first step we have to take the given data. Here we have to find the rank for a matrix means we have to find the echelon form for this matrix. Precisely, we have to find the row reduced echelon form for this matrix. Here, row reduced echelon form is first condition says all the leading entry must be unity. Here, in each row, the leading entry must be unity. Here, in the first row, the leading entry is 0. So, we have to achieve this as 1. For that, we have to apply an elementary operation as R1 is interchanged to R2. Here, the condition of elementary operation says we can interchange any 2 rows. Here we can interchange any 2 rows for this matrix. Here we can interchange these 2 rows or we can interchange these 2 rows also. So I am interchanging R1 with R2. So the newly obtained matrix is here first row is our second row. Here the first row means that is 1 0 1 1. Second row is 0 1 minus 3 minus 1. Third row and fourth row is same. That is 3 1 0 2. Fourth row is 1 1 minus 2 0. So this is a new matrix obtained if we interchange R1 with R2. So the leading entry in first row is 1 here. Next condition is below the leading entry all the values must be 0. Here this second row value is 0 already. We have to change this values as 0 and this value is also 0. For that, next the elementary operation is that is R3 we have to change this to R3 minus 3R1 and R4 is R4 minus R1. Here we have 3, so R3 minus 3R1 means 3 minus 3 into 1 we get a value as 0. Here R4 is 1, 1 minus 1 is 0. So we get a new matrix as here we apply elementary operation as this we get a new matrix as the first row is same that is 1 0 1 1. Second row is here we have 0, so no need to change this row, so that is second row is also same that is 0 1 minus 3 minus 1. Third row is 3 minus 3 into 1 is 0, that is 3 minus 3 value becomes 0. Similarly 1 here R3 is 1 here, 1 minus 3 into 0 is 3 into 0 is 0, 1 minus 0 is 1. Similarly 0 minus 3 into 1 is 3, 0 minus 3 is minus 3 here. Here similarly 2 minus 3 into 1 is 3, 2 minus 3 is minus 1. Similar way R4 is 1 here, 1 minus R1 is 1, 1 minus 1 is 0. So 1 minus R1 is 0, 1 minus 0 is 1. Similarly minus 2 minus 1. So minus 2 minus 1 is minus 3. Here this value. Here 0 minus 1 is minus 1. So we have to take the values, that is negative values or positive values correctly. So the new obtained matrix is this. Next here the leading entry in first row is 1 and below this all the leading entry, all the values are 0. In the similar way second leading entry is also 1. Next you have to achieve all the entries below this leading entry is 0. For that we have to take a elementary operation as here R3 is R3 minus R2, R4 is R4 minus R2 because that value is A is 1 0 1 1, 0 1 minus 3 minus 1, 0 1 minus 3 minus 1, 0 1 minus 3 minus 1. So to achieve this value is 0, this value is 0, we have to subtract R3 by R2, not by R1. R1 value is finished. We have to subtract R3 by R2 and R4 by R2. That is R3 is R3 minus R2, R4 is R4 minus R2. We get a new matrix as here first row is same, that is 1 0 1 1. Second row is also same, that is 0 1 minus 3 minus 1. Third row is R3 minus R2, 1 minus 1 is 0. Here this R3 value is minus 3, here minus 3 minus of minus 3, that is minus 2 minus plus, here minus 3 plus 3 is 0 here this value becomes 0. In the similar way minus 1 here, minus 1 minus of minus 1, minus 2 minus plus 1 minus 1 is 0. In the similar way R4 matrix is here first value is 0, R4 minus R2 is 1 minus 1 is 0, R4 minus R2 here minus 3 minus of minus 3 is plus 3, minus 3 plus 3 is 0 here. Here this is also minus 1 minus of minus 1 minus minus plus minus 1 plus 1 is 0. So we obtain these two values, that is these two row as 0. Therefore we obtain a value as this, that is R3, that is row 3 is also 0, row 4 is 0. Therefore we can conclude that this is a echelon form of a matrix because first row, that is the leading entry in each row is 1. Here this leading entry is also 1, here also 1, here no leading entries. Similarly the values below the leading entry must be 0, this is 0, this value is also 0. So if there is a 0 rows, you have to place it in a last. So third row is also 0, fourth row is also 0. Therefore we can conclude that there are two non-zero rows in a matrix. Here to find the rank for a matrix you have to obtain or we have to find how many non-zero rows present in the echelon form of a matrix. Since this is an echelon form of a matrix, there are two non-zero rows. This is also non-zero row, this is also non-zero row. These two are 0 rows. So we have to calculate only non-zero rows. Therefore, the number of non-zero rows in a row reduced echelon form of a matrix is nothing but a rank of a matrix, that is row of A. The rank of a matrix is equal to 2. So you obtain two non-zero row in a given matrix. So this is a rank for the given matrix. So this completes the problem. This is how to find the rank of a matrix. This is our very easy problem, that is to find the rank of a matrix. We shall move on to another problem. Find the rank of a matrix A is equal to, here first row is 1 2 4 3, second row is 2 4 6 8, third row is 4 8 12 16, fourth row is 1 2 3 4. Here first step we have to take the given data, that is A is equal to this. This is a 4 cross 4 matrix. Here next we have to find the rank of a matrix, means we have to find the echelon form for this matrix. Here first condition is the leading entry in each row must be 1. Here in the first row the leading entry is 1 obviously. Here we have second row as 2 4 6 8, third row is 4 8 12 16. These are all the divisors of 2 and these are all the divisors of 4. So to make the simplification easy, in the next step we can take a elementary operation as we can divide this R2 by 2 and R3 by 4. Since this R2, that is row 2, is a divisor of 2, similarly the row 3 is a divisor of 4, we can take this elementary operation as R2 implies 1 by 2 into R2, R3 implies 1 by 4 into R3. Or we can take this directly, we can take this as R2 is R2 minus 2 R1 and R3 is R3 minus 4 R1. Both are same, but to make the simplification easy I am taking here R2 as 1 by 2 into R2 and R3 as 1 by 4 into R3. We get a new matrix as, here first row is same, that is 1 2 4 3. Second row is, here we divide this by 2 means we get a value as, here 1 by 2 into 2 is 1, here 1 by 2 into 4 is, so 2 ones are 2 twos are 2 here. Here 1 by 2 into 6 is 2 ones are 2 threes are, here we have 3. Here 1 by 2 into 8 is 2 ones are 2 fours are. Therefore the second row becomes 1 2 3 4 in the similar way. Here 1 by 4 into 4 is 4 gets cancelled, remaining is 1. 1 by 4 into 8 is 4 ones are 4 twos are, that is 2 here. 1 by 4 into 12, that is 4 ones are 4 threes are, and 1 by 4 into 16, that is 4 ones are 4 fours are, that is we get a row as 1 2 3 4. Fourth row is same, that is 1 2 3 4. So we get a matrix value as this. Next, here the leading entry is 1 here. So next we have to achieve all the values below the leading entry is 0. For that, we can take this as here R2 implies R2 minus R1, R3 implies R3 minus R1, R4 is R4 minus R1. Therefore, we obtain a new matrix as this, because here we have A as this matrix. Here if we subtract here R2 by R1 and R3 by R1 and R4 by R1 means first this is 1 minus 1 is 0. Here 2 minus 2 is 0. Here we have R2 is 3. 3 minus 4 is minus 1. Similarly, 4 minus 3 is 1 here. In the similar way, R3 is 1. 1 minus 1 is 0. Here 2 minus 2 is 0. Here 3 minus 4 is minus 1. 4 minus 3 is plus 1. Similar way, R4 is 1 minus 1 is 0. 2 minus 2 is 0. 3 minus 4 is minus 1. 4 minus 3 is 1. Therefore, this is a new matrix. Here in the next step, we have to obtain in the second row the leading entry must be positive value, that is plus 1. Here we have this is minus 1, this is also minus 1. So we have to obtain the leading entry. Below the leading entry all the values are 0. For that we have to take this as here R3 is R3 minus R2. Here minus 1. So here also minus 1, minus 1, minus 2 minus plus 1. We get a value 0. Here also minus 1. Minus of minus 1 is plus 1. Minus 2 minus plus 1. That is plus 1 minus 1 gets cancelled. This value becomes 0. Therefore the obtained matrix as here first row is same, that is 1 2 4 3. Second row is also same, 0 0 minus 1 1. Third row is here 0, this also 0, here this value becomes 0, this also 0. In the similar way, fourth one is 0 0, here this also minus 1 minus 2 minus plus 1, that is 0 1 minus 1 is 0. So all the values are 0 here. Here the leading entry must be positive value. For that next step is here we can take this R2 as minus 1 into R2. Here multiplying negative sign we get a value as the second row becomes here first row is same, that is 1 2 4 3. Second row is 0 0. Here minus 1 is plus 1. Here minus of 1 is minus 1. Here third row is 0. This is also a 0. Therefore, this is an echelon form of a matrix here, because here the leading entry in first row is 1. Below this all the values are 0. Here in the second row the leading entry is 1. Below this all the values are 0. Here no leading entries. Here also there is no leading entries. So this is an echelon form of a matrix. Therefore, we can conclude that there are two non-zero rows. This is first row, second row is a two non-zero row. Therefore, we can conclude that the rank of a matrix is 2. So this is about rank of a matrix for this matrix A. We shall move on to another problem. Find the rank of a matrix A is equal to, here first row is 2 minus 1 minus 3 minus 1. Second row is 1 2 3 minus 1. Third row is 1 0 1 1. Fourth row is 0 1 1 minus 1. So first step, take the given data, that is A is equal to, here it is 4 cross 4 matrix. Here we have to find the rank of a matrix, means we have to find the echelon form for this matrix A. Here finding echelon form is first step is here the leading entry in each row must be 1. Here in the first row this value is 2. Here in the second row this value is 1. So we can interchange this row 1 and row 2. That's the first step. Here interchanging R1 and R2 we get a new matrix as here first row is this. Here our second row is our first row. Here second row is 1 2 3 minus 1. So we have to interchange that value. We get a first row as 1 2 3 minus 1. Second row is 2 minus 1 minus 3 minus 1. Third row is 1 0 1 1. Fourth row is 0 1 1 minus 1. So this is a obtained matrix. Next, first row, here the leading entry in each row is unity. Here in the first row the leading entry is 1. Next step, we have to take all the values here. Below this leading entry all the values must be 0. For that, second step, here R2 is 2 here. So to obtain this as 0, we have to apply elementary operation as R2. We have to take it as R2 minus 2 R1. Similarly, R3 is 1 here. To obtain 0, we have to take R3 as R3 minus R1. So the new matrix is here the first row is same, that is 1 2 3 minus 1. Second row is here R2 minus 2 R1 means 2 minus 2 into R1 is 1. 2 minus 2 is 0. Similarly, minus 1 is R2. Here R2 minus 2 into 2. Here 2 into 2 is 4. Minus 1 minus 4 is minus 5. Similarly, minus 3 minus 2 into 3 is 6. Here minus 3 minus 6 is minus 9. Similarly, minus 1 minus into minus plus 2 into 1 is 2. So minus 1 plus 2 is plus 1. Similarly, R3 implies R3 minus R1. Here 1 minus 1 is 0. Here 0 minus 2 is minus 2. 1 minus 3 is minus 2. Here 1 minus of minus 1 is plus 1. So we have 2. Similarly, last row is same, that is 0, 1, 1, minus 1. So this is our newly obtained matrix. Next step, here for this we can divide this by some value, we get a unity value. Next we have to obtain all the values below this unity value must be 0. For that we have to take this as, here R3 is 5R3 minus 2R2, R4 is 5R4 plus R2, because here A value is this, here we have minus 2. So to obtain this value 0, here R2 is minus 5. So we have to multiply by 5 for this R3 and multiply by 2 for this R2. We get here 5 into R3 is minus 2. So 5 into minus 2 is minus 10. Minus 2 into R2 is minus 5. So we get minus 2 minus plus 10. So here we have minus 10, here we have plus 10. So we get a value as 0 here. Similar way, here we have 1. So to achieve as 0 means here we have to multiply R4 by 5. Here already we have 5. Therefore 5 into 1 is 5. Plus into minus R2 is 5. 5 minus 5 is 0 here. Therefore we obtain a matrix as, here first row is same, that is 1, 2, 3 minus 1. Second row is also same. Third row is, here first value is 0. Here 0 minus 0 is 0 itself. Second value, here minus 2 is our R3, that is 5 into minus 2 is minus 10, minus 2 into R2 is minus 5. So minus 2 minus plus 2 into 5 is 10. So we have minus 5 plus 5 is 0. Similarly, for this value, here R3 is minus 2, therefore substituting R3 value as minus 2 here, 5 into minus 2 is minus 10, minus 2 into, here we have R2 is minus 9, minus 2 minus plus 9 into 2 is 18. So minus 10 plus 18, we get a value as 8. Here in this place you have to carefully substitute a value and find the number. Here in the place of R3, here we have 2. So substitute R3 as 2 and R2 value here is 1. So 5 into 2 is 10, minus 2 into 1 is 2. So 10 minus 2 is 8 here. In the similar way, R3 is here this 0, here this is 5 R4, here R4 is 1, 5 into 1 is 5, plus into minus 5, plus 5 minus 5 is 0 here. Here R4 is 1, here R2 is minus 9. So 5 into 1 is 5, plus into minus minus R2 is 9. So plus 5 minus 9 is minus 4. Similarly, here R4 is minus 1, R2 is 1. So 5 into minus 1 is minus 5 plus 1. So we get minus 4. So here this value becomes 0. Next step, here in the first row we have unity element. In the second row there is no unity element. Further, to achieve this value as 1. And in the third row you have 8 and 8. Here also we have to achieve the leading entry must be 1. Here also we have to achieve the leading entry must be 1. For that, next we have to apply the elementary row operation as, here in the place of R2 we can substitute as minus 1 by 5 into R2. This is because here R2 is minus 5 here. So to achieve for this as 1 means here minus 1 by 5 into, in the place of R2 we substituted as minus 5. So minus 2 minus plus 1 by 5 into 5, 5 gets cancelled, remaining is 1. In the similar way, for this R3 we have to take it as 1 by 8 into R3. For this R4 we have to take it as minus 1 by 4 into R4. Here also we have to achieve for 1. Here also we have to achieve for 1. Therefore, the obtained matrix as, here first row is same, that is 1, 2, 3, minus 1. Second row is, here this value becomes 0. Here minus 1 by 5 into R2 is 0. So this value becomes 0. For this R2, here substitute R2 as minus 5, that is minus in 1 by 5 into 5, that value becomes 1. Here we have R2 is minus 9. So substituting R2 as minus 9, that is minus 2 minus plus 1 by 5 into 9, that is 9 by 5. Similarly, here R2 is 1. So substituting R2 as 1 means minus 1 by 5 into 1, that becomes minus 1 by 5. Similarly, here for this R3 we have to take this as 1 by 8 into R3. Here this value becomes 0, this also 0. Here 1 by 8 into R3 is 8. So 8 gets cancelled, remaining is 1. For this also 8 gets cancelled, remaining value is 1. Similarly, for R4, that is minus 1 by 4 into R4, that is, here this value becomes 0, this also 0. Here minus 1 by 4 into R4 value is minus 4. minus 2 minus plus 4 4 gets cancelled, remaining is 1. Here also this value becomes 1. So for this first row the leading entry is 1, for the second row also leading entry is 1, and this for this leading entry below the all the values are 0. Here for this leading entry below the values are 0. Here in the third row also the leading entry is 1. Next you have to achieve all these values below this leading entry must be 0. So to achieve this value is 0, next you have to take elementary operation as you have to take R4 as R4 minus R3. Therefore we get a new matrix as here first row is same, second row is also same, third row is also same, but fourth row that is R4 is R4 minus R3. Here this is also 0, this is also 0. Here this is 1 minus 1 is 0. Here also 1 minus 1 is 0. So this is an echelon form of a matrix. Finally, the number of non-zero row is nothing but the rank of a matrix. Here we have 3 non-zero rows. Here this is also non-zero row, this is also non-zero row, this is also non-zero row. Therefore, we can conclude that rank of a matrix, that is row of A, as 3. This is the problem related to rank of a matrix. We shall move on to another problem. Find the rank of a matrix A is equal to, here this is the 5 cross 5 matrix. Here first row is 91, 92, 93, 94, 95. Second row is 92, 93, 94, 95, 96. Third row is 93, 94, 95, 96, 97. Fourth row is 94, 95, 96, 97, 98. Fifth row is 95, 96, 97, 98, 99. Here they may ask for any number, any large number, but the procedure is same for all the problems. That means we have to reduce this given matrix to an echelon form of a matrix. The number of non-zero row is nothing but a rank of a matrix. That is, first take the given data. Here our aim is to find the rank of a matrix. That means you have to find the echelon form for this matrix. First, we have to obtain, that is, leading entry of each row must be unity. Here we have largest number. So we have to take that value as next step. So next condition is below this leading entry all the values must be 0. So first we have to achieve that property. For that, take the elementary row operation is here R2 is 92, here R3 is 93, R4 is 94, R5 is 95. So we can take this as, here we have to reduce this greater value to a smaller value. So for that we are taking this operation. Here R2 is R2 minus R1. So we obtain a new matrix as, here first row is same. Second row is here 92 minus 91 is 1. Here also 93 minus 92 is 1. 94 minus 93 is 1. 95 minus 94 is 1. 96 minus 95 is also 1. Similar way, R3 minus 1. Here 93 minus 91 is 2. 94 minus 92 is 2. 95 minus 93 is 2. 96 minus 94 is 2. 97 minus 95 is 2. In the similar way, R4 we have to take is the R4 minus R1. Here 94 minus 91 is 3. 95 minus 92 is 3. 96 minus 93 is 3. 97 minus 94 is also 3. 98 minus 95 is also 3. Similarly, for the fourth row, we have to take this as R5 minus R1. That is 95 minus 91 is 4. 96 minus 92 is also 4. 97 minus 93 is 4. 98 minus 94 is 4. 99 minus 95 is 4. So we obtain a new matrix as this. Next step, R2, that is row 2 value is 1. Here the leading entry in the second row is 1. So in the next step we can achieve that below this leading entry all the values must be 0. For that we have to take the condition as R3 is R3 minus 2 R2, R4 is R4 minus 3 R2, and R5 is R5 minus 4 R2. So to achieve this value as 0 we have to take in the elementary operation as R3 is R3 minus 2 R2, R4 is R4 minus 3 R2, R5 is R5 minus 4 R2. Because the matrix is like this, here 2 minus 2 into R2, that is 2 into 1 is 2, that is 2 minus 2 becomes 0. Here also 3 minus 3 becomes 0. Here also 4 minus 4 becomes 0. Therefore the obtained matrix is, here first row is same, second row is also same. Here third row becomes, here all these values are 2. That is 2 minus 2 into R1 is 2 minus 2 is 0. Here also 0, here also 0, here also 0. In the similar way, R4 is R4 minus 3 R2. Here 3 minus 3 into R2 is 1. So we get 3 minus 3 is 0. Here also this value becomes 0. Here also 0. Here also 0. Here this also 0. This also 0. In the similar way, R5 is R5 minus 4 R2. Here R5 is 4. 4 minus 4 into R2 is 1. 4 minus 4 into 1 is 4. 4 minus 4 is 0. In the similar way, this value becomes 0. This also 0. This also 0. And this also 0. Here we have 1. Here if we obtain this value as unity element, below this unity element all the values must be 0, but here we have 1. So to achieve this value is also 0, in the next step we have to apply elementary operation as here R2 is 91 R2 minus R1. So this is because to achieve this value as 0 we have to take R2 as 91 R2 minus R1. Here 91 into R2 is 1. It is 91 into 1 minus R1 is 91. So 91 minus 91 becomes 0. So we obtain a matrix as here first row is same, second row is here 91 into 1 minus 91 is 0. Similarly here is 1, here 91 into 1 is 91 minus R1, here R1 is 92, 91 minus 92 is minus 1, here is 91, 91 minus 93 is minus 2, here also 91 into 1 is 91, 91 minus 94 is 93, that is minus 3. Similarly, here it is 91, 91 minus 95 is minus 4. Here next all the three rows are same as before. So below the leading entry all the values must be 0. That satisfies. Next step, in the second row here we have negative sign of unity. So to achieve it as positive, and also in the first row we have to take this as 1. So to achieve this as 1 and this second row we have to take a positive value of 1. For that, in the next step, we have to take elementary operation as here R1 is, here to achieve this as 1 means you have to take 1 by 91 into R1. Here R1 is 1 by 91 into R1, here 1 by 91 into R1 is 91, 91 gets cancelled, R1 is 1 here. So here R2 is, here we have negative sign, so to achieve as positive, we have to multiply by minus 1 to R2. Therefore, we obtain a new matrix as here first value is here 1 by 91 into 91 is 1. Similarly 1 by 91 into 92 is 92 by 91. Similarly 1 by 91 into 93 is 93 by 1. 1 by 91 into 94 is 94 by 1. Here 1 by 91 into 95 is 95 by 1. This is the first row. Here second row is we have to multiply this second row by minus 1, that is minus 1 into minus 1 is plus 1. Here minus 1 into minus 2 is plus 2. Here minus 1 into minus 3 is plus 3. Minus 1 into minus 4 is plus 4. Here all next three rows are same, that is 0. So we achieved an echelon form matrix as here in the first row the leading entry is 1. Below this leading entry all the values are 0. In the second row here the leading entry is 1. Below this all the entries are 0. Therefore we can conclude that this is an row reduced echelon form for a given matrix. Hence, the non-zero rows in this matrix is here, this is a non-zero row, this is also a non-zero row. Therefore, we can conclude that the rank of a matrix is given by row of A is 2. Here we have two non-zero rows. Therefore, the rank of a matrix for this problem is 2. This completes the problem. These are all some of the important question paper problems on rank of a matrix. In next video, we study about consistency of system of linear equation. If you want any problems to be solved, comment below. Thank you.